For this particular problem, the statement is telling us that the relationship between kinetic energy E, mass m, and velocity v for a moving particle is given by the formula E is equal to a half mv squared. Now, we are required to make v the subject of the formula. As a matter of fact, the statement of the problem says express v in terms of E and m. That is how it is with mathematics. Sometimes we may be given an expression from another subject area, maybe physics, chemistry, even information technology, and we are required to use mathematical principles in solving the problem. At this early level, the CSEC, CSEC examiners are taking the opportunity to just introduce us to just such a situation. Expressing v in terms of E and m is the same as making v the subject of the formula. That means we need to have v in the end all by itself, probably or preferably or even more appropriately on the left hand side of the equation, and everything else on the other side, that is the right hand side. In doing so, we need to eliminate the half, eliminate also m, and eliminate the square that we have right here. It is not always the best step, but always a very good step to eliminate the denominator. So whenever we have an expression and we have a denominator, it is always a very good step to eliminate the denominator. It is called flattening the equation or flattening the expression. So we will eliminate the denominator. We have a denominator of 2 right there. That means we need to multiply the entire expression by 2. That will eliminate the denominator of 2. As a matter of fact, a denominator is something that we divide by. Therefore, we will eliminate that denominator by multiplying by 2. By so doing, on the left hand side, we will have E multiplied by 2. So on the left hand side, E will be multiplied by 2, and on the right hand side, multiplying by 2 will eliminate the denominator of 2. Next, we will eliminate m. M is accompanying the proposed subject, which is v, by multiplication. To eliminate m, we will divide the entire expression by m. M will therefore be eliminated from the right hand side, and on the left hand side we will have 2e over m. Finally, we will eliminate the square. What is the opposite of square? The opposite of square is square root. We will take the square root of both sides, thereby eliminating the square from the right hand side, and on the left hand side we will have the square root of all of 2e over m. It is more appropriate to express v in terms of E and m, with v being on the left hand side. Therefore, we will turn the expression around, placing v on the left hand side. So there we have v is equal to the square root of 2e over m. In transposing an equation, it is always very important for us to note that in eliminating, maybe in this particular case, m we need to divide by m. But we do not just divide by m on the other side. We divide the entire equation by m. In that way, m is eliminated from this side, and on the other side we will have 2e over m. In an equation, we cannot maintain its integrity if we do not do the same thing on both sides, or we may say do the same thing throughout the entire equation. And that is why we need to divide. If we are dividing in order to eliminate this m, we need to divide both sides by m. By using that same expression, we have e is equal to 45 and m is equal to 13. We are required to find the corresponding value of v. E is equal to 45 and m is equal to 13. We need the corresponding value of v. We will therefore substitute them into the equation. We can see very quickly 2 times 45 is 90, so we will have 90 over 13. Some students may want to use their calculators and complete the calculation in one step. We may take it step by step, then use a calculator when we cannot avoid doing so, or when it is more convenient. And we have it right there that 2 multiplied by 45 is equal to 90. And those who know their multiplication tables, they all know, well, as a matter of fact, we do not study much of the 13 times table these days. As a matter of fact, when I attended school, we did not make use of the 13 times table, but experience working with numbers over a few years will just give me the idea that 13 into 90 is close to 7, because 13 times 7 is equal to 91. Therefore, we expect 6.9 something. So 90 divided by 13 is a bit awkward without the calculator. So we may use the calculator at this stage. V is equal to the square root of 6.9231. As a matter of fact, 90 divided by 13 is very close to 7, as we said before. Then we will find the square root of 6.9231, and it is highly unlikely to be a rational number. A rational number means a definite square root, not necessarily square root, but a definite root, one that we can see that will have a finite number of decimal places. So it is highly unlikely to be rational. We may therefore use our calculator again to find the square root of 6.9231. And there we have v is equal to plus or minus or positive or negative 2.63. When the square roots occur, they occur in pairs. The square of a positive and the square of a negative will be positive. There are some circumstances in which a negative square root is not applicable. For example, the length of the side of a polygon. However, v stands for velocity, which is a vector quantity that can have a positive and a negative value. In this particular case, writing both signs is necessary and sufficient. So in this particular case, when we find the square root of 6.9231, we get 2.63. We need to be reminded that when the square root occurs, it occurs in pairs. Therefore, we will have two square roots of equal size, but different in signs, because we are sure that when we square a negative, the answer is going to be positive, and when we square positive, no doubt the answer is positive. Also, v is a vector quantity, velocity is a vector quantity. Therefore, it is not going to be far-fetched or unsighting to have positive and negative values for velocity. This is a problem that I like, not only for the completed square, but for other purposes. So let's go right into it and let us enjoy ourselves. It is by the process of completing the square that we will write the quadratic expression in the following form. It is a long time since I have seen by completing the square on the CSEC examination paper. Now we always have the form. It has always been there. Over the years we make use of the form, but from time to time we will see by completing the square. It is a very, very long time since I have seen by completing the square. Recently we have the statement, more often than not, express the quadratic expression in the form. And here we have the form, and it means that we are completing the square. In completing the square, we need, well, not necessarily need, but the most appropriate thing to do is just have x squared right here, or to complete the square on an expression whose x squared coefficient is equal to 1. Therefore, we will eliminate this 3, but we cannot throw it away. If we throw it away completely, we will be changing dramatically the value of the entire expression. So we will remove the 3 and keep it at the same time. How do we do that? We will do that by making what I call a partial factorization. Taking the 3 outside of a pair of brackets, if we are going to include a negative 8x inside here, then it means that this negative 8x will also be affected by the 3. If we are factorizing, remember the principles of factorization. Find the highest common factor and divide each term by the highest common factor. No, we are not taking the highest common factor. We are factorizing. Nonetheless, we are taking this 3 in order that we may have the x squared coefficient to be 1. So we have a different motive from the typical factorization. This term will also be affected. Take the common factor, divide by the common factor. Therefore, we will need to divide 8x by 3. And that is our first step. The contents of the brackets will be a perfect square when we add the square of half of the middle term to it. So we need to add the square of half of the middle coefficient. Take half of the middle coefficient and square it. So take half of the middle coefficient. We have 8 over 3. Half of 8 over 3 is 4 over 3. Then we will square 4 over 3. Square 4, we get 16. Square 3, we get 9. So we have inside of this pair of brackets a completed square. For more detailed information on completing the square, you may consult Richard James Mathematics Resources, Volume 2. In that volume, we'll have a complete description of completing the square, and also the particular details will be discussed to some length in order to give some clarity to the entire process. But right here, I think it would not be too harsh under the circumstances to mention that the perfect square, if we square, say, a plus b all squared is equal to a squared plus 2ab plus b squared. Therefore, the middle term is 2 times the first times the second. Therefore, if we need to go to the third term, we need to take half of the middle coefficient and square it, because in a perfect square, the middle term is always 2 times the first times the second. So in order to get the second, cause x is this first, the second will be half of 8 over 3. So take half of 8 over 3 and square it. We get 16 over 9. And what do we know? We have now introduced a new term, 16 over 9, that we need to compensate for. It is also multiplied by the 3 that precedes the brackets. 16 over 9. Here we have it, 16 over 9. This is the term that we have introduced. But the entire value that is added to the expression is not just 16 over 9. Why it cannot be just 16 over 9? Because it is being multiplied by 3 that precedes the bracket. And as a matter of fact, everything inside of the bracket is being multiplied by 3. Therefore, 16 over 9 is to be multiplied by 3. Therefore, we will have 16 over 9 multiplied by 3 over 1. 3 will cancel with 9 to give 3. Therefore, we are really adding 16 over 3. If we are introducing 16 over 3, we need to eliminate that 16 over 3. So we will subtract 16 over 3 in the end. The square root of x squared, now we are writing this as a perfect square. What did we square to give x squared? X. What did we square to give 16 over 9? 4 over 3. So there we have it. Square x and we get x squared. And the square root of 16 over 9 will be 4 over 3. That 16 over 9 will be the term in the perfect square brackets. And the whole number will be written as a fraction with the same denominator as the one to which it is to be added. So what we are saying is that what do we square to give x squared is x. What do we square to give 16 over 9? 4 over 3. Now if we multiply to give this middle term, and we multiply 2 times this, and we get a negative, it means that one of them has to be negative. Therefore, we have negative 4 over 3 instead of a positive 4 over 3. Without this negative 4 over 3, it is not possible to get a negative sign right here. Also, in order to add this whole number with this fraction quite easily, we write the whole number with the same denominator as the fraction that we have right here. By so doing, we say 3 2's 6, and we put that over 3 again. So 6 divided by 3 is actually 2. However, we have a denominator of 3 right here, making it easy to combine these two numbers because they have the same denominator. And the final answer is 3 times all of x minus 4 over 3 all squared, and we have negative 10 over 3. Positive, negative. We subtract the smaller from the larger, and the answer will take the same sign as the larger. Now, I think that we are at the stage where we will have the most fun. We need to solve the equation g of x is equal to 0. This will be a quadratic that we may use any of a number of methods to solve. We have the completed square already. We will therefore solve the equation by the method of completing the square. We may solve this equation by completing the square. We may solve this equation by making use of the quadratic factor. We may solve it by factorization. Doubtful that this expression will be easily factorized. Because it is not so easily factorized, then we may use the quadratic formula, or we may use completing the square. But we have the completed square already, so we will solve by completing the square. That is the completed square. Let us solve. Now, in solving this and also every other equation, we will make use of the principles involved in transposition of formulae. Therefore, we will transpose this formula by eliminating, well, we are attempting to make x the subject in this particular case. So, since we are making x the subject of the formula in this particular case, we need to eliminate everything else from this side that contains x. The fact that everything else is represented by not letters and symbols but by numbers, we are sure that when we get to the other side we will have just a single expression. As a matter of fact, this is just a matter of manipulating algebraic expressions. So we'll just have from time to time only a single number necessarily on the right hand side. So we will eliminate this negative 10 over 3 by adding 10 over 3 to both sides. By so doing, negative 10 over 3 will be eliminated on the left hand side, and on the right hand side we will have positive 10 over 3. Then what do we eliminate next? We will eliminate this 3. But what is the rule that governs the one that we eliminate first? The rule is eliminate the one that is least related to the proposed subject. And in this particular case, this 3 is the one that is least related. We will eliminate that 3 by dividing by 3, because it is being multiplied by 3 here. Divide by 3 on both sides. 3 will be eliminated from the left hand side, and on the right hand side we will have the 3 multiplying this 3 in the denominator. Right, when we divide, the number will go into the denominator to multiply. Therefore, we will have 10 over 9. Next, we will eliminate, as the rule says, the one that is least related, and we know that is the square. We eliminate the square by taking the square root of both sides. By doing that, the square will be eliminated on the left hand side, because the opposite of square is square root, and on the right hand side we will have 10 over 9, the square root of all of that. Finding the square root of both sides will eliminate the square from the left hand side, and we will take the square root of the right hand side. There we have it. It is a matter of how we will proceed right here. So we need to take the square root of this side. Maybe we will eliminate this negative 4 over 3 first, or both of them at the same time. Eliminate this negative 4 over 3, we will know that we need to add 4 over 3 to both sides. And the negative 4 over 3 will be eliminated from the left hand side. On the right hand side, we have positive 4 over 3. But do not forget that the square root occurs in pairs. So recall that the square root occurs in pairs, and write the fractions as decimals. We're going to do that. So we have this written as a decimal is negative 1.33. It will continue. It's a recurring decimal. Just writing to 2 places of decimal. This one, the square root is plus or minus, positive or negative 1.05. And as we discussed before, we will eliminate this negative number from the left hand side by adding 1.33 to both sides. And on the right hand side, we will have all of that plus 1.33. Then we will do the necessary simplification. 1.33 plus 1.05 is 2.38, and 1.33 minus 1.05 is 0.28. And as we move merrily along, the solution will get to be more enjoyable, no doubt. There we have the curve. Usually we are required to sketch the curve. Now this curve is already sketched for us, and we are required to insert values at A, B, and C. And I don't think that the CSEC examiners are trying to simplify this problem. I think it is another take on the problem. I think they are just being flexible, and I like a variety of approaches to problems, and we may not do that as much as we can if we do not have problems written in a variety of ways. So this one I find to be very interesting and enjoyable. It's a very good gesture by the CSEC examiners. A sketch of the graph of g of x is shown right there. We need to state the y-ordinate of A. So there we have our expression. We need to state the y-ordinate of A. The point A is the y-intercept, where the curve crosses the y-axis. And what do we know? Its value is a constant value in the original expression. So there is our original expression, and there is a constant value. The constant value is always the y-intercept. Why is it the y-intercept? Because it occurs when x is equal to 0. That is, on this axis, x is equal to 0. If we put 0 here, 0 here, then this term will be equal to 0, this term will be equal to 0, and all that will be left is 2. Therefore, we are sure that 2 is the y-intercept, and we have inserted it right there. We have something else. C is an x-intercept. Why an x-intercept and not the x-intercept? Because we have an x-intercept right here, and we have another x-intercept right there. So we are sure that we have two of them, but C is only one of them. So C is an x-intercept that occurs when f of x is equal to 0. It is therefore one of the solutions of the equation. There we have the solutions of the equation, and C is one of them, because C is an x-intercept. It occurs when f of x, in this particular case, is g of x, where g of x is equal to 0. Therefore, g of x is equal to 0 along this x-axis, and this one is one of the point of intercept, and this one is another intercept. There are two x-intercepts. C is the one to the right, and is therefore the one greater in value. C is the one to the right, and therefore the one that is greater in value. That is C. If we are going along this x-axis, we know that we increase in this direction. C is the one out here, has to be the one greater in value. Therefore, let us put that in. 2.38. Very nice. What do we know? We are required to insert the x and y coordinates of B. How do we do that? And this is why I enjoy this problem, because beforehand we have completed this square. We have used the completed square in solving the equation. We have used the solution of the equation to determine the x-intercept C. And we are using the completed square again in determining the x and y ordinates of B. And some candidates may be a bit hesitant, or may I say terrified, by a problem like this, because they may be saying, if I got those answers wrong, then all of my answers that follow will be wrong. The fact is, CSEC does not punish you or penalize you for cascading errors. Therefore, if you make an error only as a consequence of making a previous error, you will be only penalized for the previous error, and you will not be penalized for any subsequent error that is a direct consequence of the previous error. If it is by some other means, or if it is by the previous error, then by another error to compound the problem, then you will continue to lose marks. But if it is only as a consequence of that error, then you will not lose any mark. Now we have the completed square and we are making use of it. B is the minimum point on the curve. Its coordinates may be determined from the completed square. The constant value outside of the brackets in the completed square is the y ordinate of the minimum point. It occurs, or the minimum occurs, when the expression inside of the brackets is equal to 0. That is, when x minus 4 over 3 is equal to 0. Everyone can solve that equation to give x is equal to 4 over 3. That is the value, 4 over 3, and it goes right there. Right. So, this is by no means a simplified version of a problem that requires you to sketch a curve. It is just another take, another approach that is required to the solution of a problem that has to do with curve sketching. And I take my hat off for the CSEC CSEC examiners. Now we have our linear programming problem, and we have our first constraint. Maybe the first of two constraints, but it's the first constraint nonetheless. The manager of a pizza shop wishes to make small pizzas and large pizzas. His oven holds no more than 20 pizzas. The total is no more than 20. It is therefore less than or equal to 20. No more. It can go up to 20, but it cannot be more. It has to be less. So x plus y is less than or equal to 20. The ingredients for each small pizza cost $15 and for each large pizza cost $30. The manager plans to spend no more than $450. So what do you know? The amount of money spent is equal to the cost of the items multiplied by the number of each, but cannot be in excess of $450. To graph a straight line, we need 2 points, and that is the premise by which we will graph these two lines that we have represented by the inequalities that we have right here. Because of the way in which the inequalities are written, the following strategy will be used to graph the line. Just like in any set of circumstances, we are playing cricket, we imagine that we will go out there and bat the ball. But sometimes the ball is a little bit full, sometimes it's too short, sometimes it's a good length. We will play each ball on its merit, and we will graph each line on its merit. In this particular case, the most convenient way to graph a line that is given with the x and y's on the left hand side and the pure number on the right hand side is to equate each one in turn to 0. So we will say for the first line, let x equal 0. If that be the case, we will have 0 plus y is equal to 20. Now we are graphing the lines that are associated with the inequalities. So we have 0 plus y is equal to 20. And if that be the case, then y is equal to 20. That's not difficult. And for this same line, what do we say? Equate y to 0, then x plus 0 is equal to 20. X is equal to 20. That also is pretty much straightforward. The other is a bit straightforward also, but just has a little bit more twist to it, because on this left hand side for this particular equation we have the coefficient of x is 1, the coefficient of y is 1. Now we have just a little bit greater degree of difficulty with the coefficient of x not equal to 1 and the coefficient of y not equal to 1. The line passes through 0 for the x and 20 for the y, and over here we will have what? 20 for the x and 0 for the y. We will do the same for the other line, taking the same approach, equating x to 0, then equate y to 0. But before we do that, we may simplify the equation by dividing through by 15. So 15 into 15x is x. 15 into 30 is 2. 15 into 45 first. Actually, it is 450. But 15 into 45 is 3. So 30. X plus 2y is equal to 30, and that is simpler to graph. When x is equal to 0, we say that again. When x is equal to 0, then 0 plus 2y is equal to 30. 2y is equal to 30. Y is equal to 30 divided by 2. Y is equal to 15. Y is equal to 0. Say y is equal to 0. In this particular case, it is more straightforward. This one is 0, x is equal to 30, and that is all there is to it. The line passes through, what does it pass through? 2 points. What are they? X ordinate is 0, the y ordinate is 15. The x and y coordinates are 0, 15. Then it will pass through another point. The x ordinate in this particular case is 30. The y ordinate is 0. This one will pass through the pair of coordinates 30, 0. Then we will graph them on the other slide. There is our nice grid. For the first line, plot the points 0, 20. 0 and the y value is 20. 20, 0. 20 and the y value is 0. Draw the associated line. Just draw that line through those 2 points. That's good enough. The second line passes through the points, if we can remember them. If we can't, we have them on the slide. 0, 15. The x is 0. No movement in the x direction. Not 1. Not 1. So no movement in the x. 15 on the y. Then the other one is 30 on the x. No movement on the y. And there we have another line. And what do we do after graphing the inequality? Shade the region that satisfies all of the inequalities, and also the trivial inequalities. X is greater than or equal to 0 and y is greater than or equal to 0. It is what? Trivial inequality. It is called trivial inequality. Why trivial? Because we just take it for granted. But it's not that it has no use. We are always in the linear programming problem making use of tangibles. Because of that, tangibles are not usually associated with negative values. So all of the values will be greater than or equal to 0. In this particular case, we are talking about pizzas. We will not have -5 pizzas. And don't talk about after you have eaten 5 pizzas. That does not make it negative. So we have all positive values in problems that pertain to linear programming. Therefore, we have trivial inequalities. X is greater than or equal to 0 and y is greater than or equal to 0. So shade the region, and we have here we need to shade the region satisfying the inequalities. Trivial inequalities, x is greater than or equal to 0 and y is greater than or equal to 0 are included. The x-axis has equation y is equal to 0 and the y-axis has equation x is equal to 0. Therefore, the region must also be bounded by the axes. Very good that we have this information mentioned on this slide, that the equation of the x-axis is y is equal to 0 and the equation of the y-axis is x is equal to 0. Therefore, the region has to be bounded by the x and y axes. There is our region of interest. Next, write the coordinates of the vertices. We have the first vertex. That one is one of the vertices that we have up here. So that one is 0, 15. Then the other one, we do not have it there, is 10, 10. 10, 10. And the other one is no doubt 20, 0. No doubt 0, 0. The least of these, my brethren, 0, 0 is not to be left out because it is one of the pair of coordinates of the region of interest. We will use the objective function to determine the profit associated with each coordinate. Where is our objective function? The pizza shop makes a profit of $8 on the sale of each small pizza and $20 on the sale of each large pizza. All the pizzas that were made were sold. That has to do with our objective function. $8 on each small and 20 on each large. So we have the profit is equal to the cost of the small multiplied by the number of small, and the cost of the large multiplied by the number of large pizzas. As a matter of fact, not cost, but the profit made on each one. For that vertex, which is 0, 15, we have 8 multiplied by 0 and 20 times 15. The result is $300. Then we have another one. 8 tens and 20 tens. Put those together, we get 280. Then we get 20 times 8 and 20 times 0, $160. The final coordinate 0, 0 will not yield any profit. We do not need to include that. Its profit will be 0. That one is our maximum profit, $300. The diagram comes nicely fitted with the bearing of 116 degrees, which is the bearing of Q from R. The bearing of Q is taken from R. And if that be the case, then there is required to be a line that goes from R to Q. Since the bearing is taken from R, the angle needs to be at R. Not only that, but it needs to begin at north and travel in a clockwise direction. So the bearing of Q from R will be the angle that the line RQ makes with the north line if we travel in a clockwise direction. We are told that the bearing of P from R is 242 degrees. That is now the bearing of P from R is 242 degrees. What does that mean? That means that there's a line that goes from R to P. Since it is taken, the bearing that is taken from R, the north line needs to be at R because the angle needs to be at R. That is the angle that represents the bearing. Now, we need to go in a clockwise direction beginning at north at R in a clockwise direction until we encounter the line that goes from R to P. And that angle will be the bearing of 242 degrees. And what we need is that angle that we have shaded right there. Let us now find that shaded angle PRQ. It is the difference between the two bearings, as we can see. One goes all the way around here, one comes and ends right here. So the angle that we have is the difference between the two of them, and that is equal to 126 degrees. PR is equal to 38 meters and QR is equal to 102 meters. Let's insert those. Of course, we know that we are not just playing around putting in values or the length of lines in a diagram. We will make use of them. We need to find the length PQ. In any situation that we have two sides of a triangle and the angle that those two sides form, we may use the cosine rule to find the other side, that is the one that is opposite to the angle. So we have two sides and a known angle. We may find the other side. There's only one other side. We may find the other side, and that side is opposite to the known angle. The cosine rule may be used in that particular case. And as we have it highlighted here, we have two sides of a triangle in the formula. These are the two sides of the triangle that we have These are the two sides of the triangle that we have. And the angle that the two sides form, the angle that the two sides form. And we will find the side, which is the other side, the side that is opposite to the angle, which is this one that we are attempting to find. And we will have another code on the next slide. There is the application of the cosine rule, in which, as we have them in blue, the two sides that form the angle, the two sides that form the angle will be here and will be here also. The angle that the two sides form in red, this is the angle the two sides form. These are the two sides formed by this angle. Here we have also the angle. The angle goes there, and we are trying to find this one, the side that is opposite to the known angle, or the angle that the other two sides form. From here on, it is just arithmetic manipulation. So PQ squared, we square 38, we square 102, and in this particular case, we multiply 2 times 38 times 102 right here, and we find the cosine of 126. Then we will add these two, and no doubt these two, one multiplied by the other, negative multiplied by negative, is positive. So PQ squared is equal to 11,848 plus 4,558. And as I said before, it is a matter of arithmetic manipulation here on. Now we have PQ squared is equal to 16,406. Therefore, PQ is equal to the square root of 16,406. And do not forget that when square roots occur, they occur in pairs. But why do we only have one right here? Because we are talking about the length of a side of a triangle. That cannot be negative. We will pretend as if the negative square root does not exist in this particular case. So PQ is equal to 128 meters. When applying the cosine rule, do not be dazzled by the appearance of the symbols in the formula. Just know that we are just using the two known sides of a triangle and the angle that they form in order to find the length of the side that is opposite to the angle. Two sides of a triangle, two sides of a triangle, the angle that the two sides form, and the unknown side right there. The diagram is given to us with the points K, L, and M. The vertical pole KS may be located at K. Of course, if we have a vertical pole KS, it must be located, or at least have something to do with K. So the vertical pole we have at KS, K, S, and we have information that the pole is actually 10 meters in height. Complete the diagram to show angles of elevation of S from L and from M. So we will have two, or be considering two angles of elevation of the point S. One will be taken at L and the other will be taken at M. Put those in. As we have right there, we may now include the angles of elevation, but be sure to place the smaller value at the smaller angle. I don't know why sometimes students do it the other way around. Maybe they are thinking about the distance from the base and they will just put the 21 degrees here and the 14 degrees here, or they get a little bit careless because it is so simple. They just throw in the two values and they fall in. at the wrong position. Now, what do we need to do? Find the length of KL by using that triangle. KL is what we need to find. But before we label that triangle, we can see that if we need to find KL, the side that is known is this one that is opposite to the angle 21 degrees. And KL is adjacent to it. Opposite and adjacent tan. Right. So this side is opposite, this one, see, opposite to the known angle. No doubt the hypotenuse is the longest side and opposite to the right angle, and that is a hypotenuse. And how do we know that this is a right angle? Because we have horizontal ground and we have vertical pole. Horizontal and vertical are always perpendicular to each other, 90 degrees to each other, right angles to each other. We need to find KL. It is the side that is adjacent to the 21 degrees angle. In the smaller of the two right angle triangles, the side opposite to the angle is known. The tangent trig ratio is therefore applicable. So we have the opposite known and the adjacent we need to know. Opposite and adjacent implies tangent trig ratio. So the tangent of 21 is opposite over adjacent. We do not know the adjacent, but we know the opposite to be 10. And as soon as the students see this, they write down KL is equal to 10 tan 21. But do not forget that we are dividing by KL here. We multiply by KL on the other side. Then, need to find KL. It is being multiplied by 21. Divide by tan 21 on the other side. So KL is actually equal to 10 over tan 21, which is equal to 26.1 meters. Some students are a bit hasty or self-programmed. As soon as the initial statement of the problem is made, they write down 10 tan 21. We need to be careful to make the correct substitution and transposition, hence resulting in 10 divided by tan 21 instead of 10 tan 21. We need to find the length of LM right here, this one. And as soon as we see this problem, how can we find LM? We are going to make use of this little triangle here. This is 21 degrees. Then we put in another angle here. Let's see what else do we know. And we made a meal of the problem. But if we use common sense, we will see that LM is a part of the distance all the way out here. And we know this one already. What if we were able to tell the entire distance? Then we will subtract one from the other. And LM would have been known immediately. The two calculations are analogous to each other. The second one may be shortened in the interest of space and time, just as would have been expected under examination conditions. So we are about to find LM, and in finding LM, we will find KM, which is pertaining to the large triangle, that one. So KM is pertaining to the large triangle, and KL is the one that we have calculated already. So if we can find KM now, then the difference will be LM. In finding KM, we know that it is analogous to the one that we have done before. That means one may be used to help in solving the other. They have similarities. So there we have our new situation. We have the opposite again, and we need to find the adjacent again. We make use of the tangent trig ratio again. But because we have gone through the entire initial setup and the transposition already, we know the form that the final statement will be in. Therefore, we do not need to reinvent the wheel. Again, the opposite side is the same, but the angle in this particular case, that's the only difference, is 14 degrees. Not quite the only difference, because as a consequence, we will have another hypotenuse, different hypotenuse, and we have a different adjacent side. When solving by analogy, the similarities are assumed and we pay special attention to the differences. So we start off by saying Km is equal to 10 over tan 14, because we had KL is equal to 10 over tan 21. And we finish in a short space, because under examination conditions, this is what would have been expected of the students. So we may go straight ahead and make our calculation short in the interest of time and space, effort and energy. Lm is equal to Km minus KL. We have said that about 5 times already, and it is obvious. Do the subtraction and the answer is 14 meters. Candidates need not get caught with 10 tan 21 for 10 divided by tan 21. In a right angled triangle, any angle that is less than 45 degrees has to be the smallest angle and must therefore be opposite to the smallest side. We will therefore expect that the sides adjacent to 21 degrees and 14 degrees must be longer than the opposite side. Sometimes an incorrect answer just does not look right. We may therefore take a second look at it. This may well be a little bit more than a mouthful, but we will clarify this situation on the next slide, where we more or less state the obvious and point out a few additional facts in making ourselves clear. Let us take a look at the statement that we made on the last slide. Candidates need not get caught with 10 tan 21 for 10 divided by tan 21. In a right angled triangle, any angle that is less than 45 degrees has to be the smallest angle and must therefore be opposite to the smallest side. We will expect that the sides adjacent to 21 degrees and 14 degrees must be longer than the opposite side. Sometimes an incorrect answer just does not look right. We may take a second look at it. What I'm saying is that the side that is opposite to that 21 degrees angle must be less than the side that is adjacent to the 21 degrees angle. And on this and the subsequent slides, we will take a look at why this has to be so. It is important to note that for any triangle, there is a direct proportionality between the sizes of the angles and the sides opposite to them. We will therefore expect that the largest angle will be opposite to the longest side, and the smallest angle will be opposite to the shortest side. So there we have a scalene triangle, and we have labeled y the side opposite to it, x the side opposite to it, Z, the side opposite to that angle Z. X is the longest side. It is opposite to the largest angle, which is the angle capital X. Z is the shortest side. It is opposite to the smallest angle, which is capital Z. This makes a lot of sense because the size of an angle is like a span. The greater the span, the greater the length of the side that will encompass it. So we have the smallest angle is Z. The side opposite to it must be the shortest side. The largest angle is X. The side opposite to it has to be the longest side. That makes a lot of sense. Let us consider our right angle triangle and see how much it fits into the context of our recent discussion. Now we are going to do that for a right angle triangle. Make use of some facts. The right angle is equal to 90 degrees. So the right angle is equal to 90 degrees. Since all angles of a triangle add to give 180 degrees, the other two angles together will be equal to 90 degrees. We take the right angle, which is 90, from 180 degrees, and the rest is 90. Therefore, if this one is 90, the other two will have a sum of 90 because the angles will add to give 180 degrees. Since the other two angles must add to give 90 degrees, each one of them must be less than 90 degrees. Well, if they add to give 90 degrees, both of them must be less than 90 degrees, because if one is equal to 90 degrees and the other is equal to 0, then we will not have a triangle. We will end up with a straight line. So, as long as we can see that we have a polygon, a right angle triangle, we are sure that if one angle, there's no doubt that one angle has to be 90 degrees, that is the right angle. The other two will add to give 90 degrees. Each one has to be less than 90 degrees. Therefore, the largest angle has to be the right angle. In a right angled triangle, the largest angle is the right angle, and it is therefore opposite to the longest side. Right, so the largest angle has to be opposite to the longest side. Therefore, the 90 degrees angle in a right angled triangle is the largest angle. It is opposite to the longest side. Right. That is why the hypotenuse of a right angled triangle must be the longest side, because in a right angled triangle, the largest angle is the 90 degrees angle. The hypotenuse is opposite to that one. It has to be the longest side. Because the other two angles of a right angled triangle add to give 90 degrees, if they are equal, then the triangle is also isosceles. So if one angle is 90 degrees and the other two angles are equal, then we are going to have two equal sides. So two equal angles will mean two equal sides, and we have an isosceles triangle. Therefore, each angle will be half of 90, because the remaining 90 degrees will be shared equally between the other two angles. So each one will be 45 degrees. The size of each angle will be 45 degrees. If not, one will be greater than 45 degrees and the other will be less than 45 degrees. So as long as the other two angles of a right angle triangle are not equal, one has to be greater than 45 degrees, the other will be less than 45 degrees. With the right angle already being the largest angle, the angle that is smaller than 45 degrees will be the smallest angle. and has to be opposite to the smallest side of the right angle triangle. So if we have an angle that is less than 45 degrees in a right angle triangle, it is the smallest angle and has to be opposite to the smallest side. There we have our previous situation that we are making a discussion on. We have 21 degrees. This 21 degrees is less than 45. Therefore, it has to be the smallest angle in this triangle. Therefore, the side that is opposite to it has to be the smallest side. Therefore, if we are finding KL, then KL has to be longer than this. Of course, it has to be longer than the shortest side. We have established that this has to be the shortest side. This angle is 90 degrees, and this angle is less than 45 degrees. This one has to be greater than 45 degrees. It has to be the smallest angle. The smallest side has to be opposite to it. KL will have to be greater than 10 meters. Considering the small right angle triangle, we know that the largest angle will be the right angle. The smallest angle has to be the 21 degrees angle because it is smaller than 45 degrees. The smallest side has to be opposite to it. This means that SK that we have is 10 meter must be shorter than any other side. It has to be the shortest side of that triangle. KL must be longer than it. KL has to be longer than KS, which is 10 meters, because it is this one opposite to the smallest angle and must therefore be the smallest side, the shortest side. This one is therefore longer. Look at what we have here. 10 over tan 14 is equal to 14.1 meters, and 10 tan 14 is equal to 2.5 meters. Which one is correct? Obviously, 10 tan 14, which is equal to 2.5 meters, has to be incorrect, because we are sure that the 10 meters, being the shortest side of the triangle, has to be smaller than any other figure that we are going to calculate that pertains to one of the sides of the triangle. Therefore, 2.5 meters shorter than 10 meters cannot be correct. KL cannot be equal to 10 tan 14, which is equal to 2.5 meters, because it is less than 10 meters, and we have already established that 10 meters has to be the shortest side of the triangle because it is opposite to the smallest angle. It is not impossible to make use of the foregoing information and still get the problem wrong. However, the error should not be that the calculated value is smaller than 10 meters. Knowing the relative size of the sides of a triangle may prove to be very useful, especially when the error has to do with whether to divide or multiply. So if the error has to do with multiplication or division, we are sure that if it is only for multiplication and division, we are sure that the error can be avoided by taking a look at the relative sizes of the sides of the right angle triangle. However, there is another error that is possible, in which the student might use the wrong trigonometrical ratio. So if the wrong trig ratio is used, then we are sure that we will get the problem wrong. We will have the wrong answer in the end. But if it is just merely, say for argument's sake, we have the correct trig ratio, if it is just to determine whether to multiply or divide, then knowing the relative sizes of the sides of the triangle may help us in totally eliminating that error. Now we have a particular situation that at first sight is capable of even driving the fear of hell in Richard James. However, just by taking a second look at the situation, it is not so difficult to satisfy the desires of the examiners. As a matter of fact, we will just go through the process and demonstrate how simple this may be done. First thing that we are required to do is to determine the angle GFH. That's the first thing that we need to do. First thing that we need to do, determine the size of the angle GFH. In finding angle GFH, let us make use of the fact that of angles subtended by the same arc, the one at the center is twice the one at the circumference. So this angle is subtended by this chord, it is subtended by this arc, and so is this angle that we have at the circumference. The one at the center is twice the one at the circumference. Therefore, the one at the circumference is half of the one at the center. And we have angle GFH is equal to 88 degrees divided by 2, 44 degrees. And we have conquered, defeated our first foe. Next is angle GDE. We need angle GDE. So why do we highlight a quadrilateral? We know that quadrilateral that has anything to do with circle theorem that may be used, having any significance at all, has to be a cyclic quadrilateral. So there we have the cyclic quadrilateral. To find GDE, angle GDE is based on the fact that opposite angles of a cyclic quadrilateral are supplementary. They add to give 180 degrees, opposite angles of a cyclic quad. One angle is 126 degrees. The one opposite to it is the rest of 180 degrees. It is 54 degrees, and we are happy. As a matter of fact, that is how it is when we are solving problems and we have defeated two parts of it. Then the other part is not so difficult. As a matter of fact, maybe have the same difficulty, but because we have removed a bit of the load from our heads, then we are moving nice and easy as we finish up the solution of our problem. There we have a triangle. It is required for us to find the angle DEF and maybe DEH, but I think it was given as DEF as a matter of unsighting us, or maybe assisting us, because if we can see that is DEF, it is easier to see that it is a part of the triangle than if we just take DEH. So it is quite likely more to our advantage to give us DEF rather than DEH. So DEH, what do we know about it finally? Angle DEF or DEH is based on the fact that the sum of all of the angles of a triangle is equal to 180 degrees. We have the other two angles. DEF is what remains after subtracting them from 180 degrees. So we have this triangle in which we have 54 degrees here, 44 degrees here, and only this one is left unknown. Put them together, subtract them from 180, and we get 82 degrees. Very nice. Next, we are required to make use of the fact that the radius of the circle, which is given to us as GC, is equal to 4 centimeters. It is good if we recognize immediately that GC is the radius of the circle, because by so doing we will realize that GC and CH are equal to 4 centimeters, both of them being radii of that same circle. So we begin by inserting those two dimensions, 4 centimeters, CG and CH. So there is our triangle that we are focusing on at the moment, because it says calculate the area of triangle GCH. Calculate the area of that triangle. Do not forget that the area of any triangle may be found by taking half of the product of any two sides and multiplying the result by sine of the angle that the two sides form. As long as we have two sides, any two sides of a triangle, and we have the angle that those two sides form, then we may go straight ahead and find the area, because the area will be related to the two sides that we know and the angle that those two sides form. Area is equal to half AB sine C, where A and B are the two known sides and C is the known angle, the angle that they form. In this particular case, A and B are equal to 4, and the angle is 88 degrees. Half 4 sine 88 will give us 8 centimeters squared, or 8 square centimeters. The area of a sector is a fraction of the area of a circle. The fraction that it represents is determined by the angle associated with the sector and the angle of an entire revolution. So the area of a sector is a fraction of the area of the circle, and that fraction is determined by the angle that is associated with that sector. So that angle is divided by the angle of an entire revolution, which is 360 degrees. So the fraction is that angle over 360 degrees multiplied by pi r squared, which is the area of the circle. When we put those together, we get 88 over 360 multiplied by 22 over 7 times 4 squared. And that turns out to be 12.3 centimeters squared. Finally, we are required to find the shaded area right here. And the shaded area is the difference between those two areas. One is the area of the triangle and the other is the area of its associated sector. The area of the shaded region is what remains after subtracting the area of the triangle from the area of the sector, which is basically a nice and easy way to finish the problem, although on a whole the problem itself is not very difficult. So things are not always as difficult as they seem. The figure not drawn to scale shows 3 points, 0, 0, which is the origin, by the way. A is 5, 0 and B is negative 1, 4. And what are we required to do? Express in the form, and we have the form that we need to express in the vector OB. So we need to find the vector OB. The vector OB is going from the origin to the point B and is therefore the position vector of B. This is typically represented by writing the coordinates of B in a column matrix known as a column vector. Any vector that goes from the origin to another point is the position vector of that point, and in writing down the position vector of that point, we write the ordinates in a column matrix. Next, we are required to find OA plus OB. OA plus OB is the sum of the position vectors. So the sum of the vector OA and the vector OB. So add those, and 5 plus -1 is 4, and 0 plus 4 is 4. And that is all there is to it. Do not worry. Well, no one should really get this one wrong, but say, for argument's sake, if it were wrong, then we are sure that by adding 5, 0 to the wrong thing, the answer would have been wrong, but the student would not have lost any marks because the error was made here and you would have lost the marks here already. So all we needed to do was just add these two. M is the midpoint of AB. This is determined by finding the average of the x ordinates and the average of the y ordinates, and that we have done when we are doing equation of a straight line. But maybe some students would be just taken up with the two vectors that we have and cannot, in a matter of a few seconds, wean themselves of the thought that we are just moving towards a pair of coordinates and then make a meal of the problem. It will be especially so that we are at number 13, getting closer to the end of the examination. Time may be running out, so we have less time to think. But let us just take note of the fact that, as usual, we take the average of the x ordinates and the y ordinates, and we are not required in this particular case to write down the midpoint, but to determine the values of x and y. So x is equal to 2 and y is equal to 2. Good if we realize that a part of the calculation was done in the previous section. Here, putting the values together. I hope no one was blinded by the fact that the vectors were required in the previous sections. All we need now is the values of x and y. Supplying them will answer the question. Maybe the examiners expected us to just put 4 over 2 instead of going through all of this, because we have values from the previous parts of the problem already. Lovely. As a matter of fact, for myself, just by looking at it, I'm not necessarily terrified by it. Taken aback by the information and how it is given and the crisscrossing that we have right here. Whenever you go to an examination and you see a problem that appears to be difficult, that is a problem that you should attempt. Cannot be too hard. If you see a well-worded problem, not very difficult, because it is well-worded in order to give you as much detailed information as you need. So those are the principles that I use in solving problems when I'm doing an examination. It works 100% of the times. That is our situation. But before we jump in the deep end, let us learn to swim. Based on the information given, we may insert labels of vectors that we may find useful in our calculations. So if we put some stuff there based on the information inside of that diagram, then we may make our calculations simpler in the end. So what will we insert first? EF is 3 times EH. So E to F is 3 times E to H. Therefore, if EF is 3 times EH, what do we know? EH is equal to U. Therefore, E to F is 3 times U. E to F is 3U. But one of the U is cut off right here, so we only have another 2 U's over there. So HF is 2U. Right. So EF is 3, EH is equal to U. Therefore, EF is 3 times U. HF is the difference between EF and EH, which is 3U minus U, which is equal to 2U. Right. I like very much the way that this statement says it right here. It is said in a short space and with, I think, more clarity than just looking at the diagram. So we say that the entire thing is 3U. This is U. Take away U from the entire thing, we are left with 2U. That is so logical and simple. M is the midpoint of OE. OM is equal to V, therefore ME is equal to V also. So M is the midpoint here of OE. This from O to M is V. Because it's midpoint, M is midpoint, over there is V also. MF is equal to 5 mg. This follows that mg is 1/5 of mf. Let us make this notification on the diagram. We may find it useful in the final analysis. So mf is 5 times mg. So mg is 1/5 of mf. We may find it useful in the final analysis. Just put it right there. We have not started to solve our problem as yet. We may now go straight ahead and find the vectors on the next slide. What are the vectors? HF is the first one, and it was discussed on the previous slide. 2U, we have it right here as a matter of fact, so no difficulty seeing that it is 2U. Anything else? By moving, let us write down the vector MF. Go from M to F. But how do we do that? Go from M to E, then from E to F. But from M to E is V. From E to F is what? From E to F is what? U plus 2U, which is 3U. So simplify the expression, we get MF is equal to V plus 3U. V plus U plus 2U. V plus 3U. That's very nice. Is there another very nice and simple vector that we need to find? A vector is a movement. Make use of the movement from O to H in order to write down the vector OH. V plus U. Right. So we have V plus U. So 2V plus U. Lovely. But I have this feeling deep inside that the next step will not be as simple. Let us take a go at the vector OG. Remember that mg is 1/5 of mf. Let us take a go at the vector OG. What do we know? mg is 1/5 of mf. So let us go to OG. So what is OG equal to? OG is V plus 1/5 of mf. Right. V plus 1/5 of mf. Nice. But do we know mf? Of course we do. Remember that the vector MF is equal to 3U from the previous slide. Remember what MF is equal to from the previous slide. Let's not go over there. Let's just write it down. So V plus 1/5 of V plus 3U. How do we work this out? V plus 1/5 of V plus 3U. Good that we labeled our diagram appropriately. Simplify the expression by making use of the fact that V is equal to 5V over 5 in order that every term may have the same denominator. So we will no doubt have V over 5 because we are multiplying by 1/5 and 3U over 5 because we are multiplying by 1/5. But in simplifying our calculation, let us write V as 5V over 5 in order that all of them will have the same denominator. In the end, because they have the same denominator, it will be easy to add. So we have 5V over 5, which is, of course, cancel this, we still have V, but it's in the form. So we will have what? 5V over 5 plus V over 5 is 6V over 5, or 6 over 5V. And we have 3 over 5U. As a matter of fact, you can see immediately that 2, 1, 6, 3, 2, 1. We can see that. And sometimes when we are solving a problem, as good mathematicians, we will have a tendency to develop the capability of kind of seeing where the problem is going before we get there. So my take on it is that since we have right here 2V, when we take out a common factor right here, as we can see, if we take 3/5 out, we will have 2. So 3 into 6 is 2, and 3 into 3 is 1. So we have 2V, we have right here 2V plus U. And it is going to be parallel to another vector. And maybe we will be required to say that 3 points are collinear. So rewrite the vector OG by taking a common factor of 3/5. So if we take out the 3/5 here, 3 into 6 is 2. So we have 2V plus U. No doubt. Right. Recall the vector OH from the previous slide and compare it with the vector OG above. So there we have our vector OH to be compared with OG. What do we know? We have 2V plus U here and V plus U right there. And we have 3 over 5 right there. No doubt, this vector is a multiple of this one. If two vectors exist in such a way that one is a multiple of the other, then we are sure that the vectors are parallel. Therefore, the points OG and H are collinear because the two vectors only involve 3 points. When the two vectors only involve 3 points and they are parallel, then the points are collinear. Now, one, we show that points are collinear if two vectors involving them are parallel, and two, vectors are parallel if one may be written as a scalar product of the other. So if one vector is a scalar product of the other, as we can see right here, then we are sure that the vectors are parallel. And if the vectors are parallel, and if there are only 3 points involving the two vectors, then we are sure that the points are collinear. So there we have matrices L, N, and M. The first thing that we need to find is L minus N squared. Before we may be able to do that, we may, not a matter of fact, we need to determine the matrix N squared. So our first duty is to find the matrix N squared. In finding the square of N, we multiply two occurrences of N together. And in the usual fashion, we have row by column. So we have -1, -1, 3, 0. The upper with the left, the answer goes to the upper left. Then we have -1, 3, 3, 2. The upper with the right, and the answer goes to the upper right. We have 0, -1, 2, 0. The lower with the left, the answer goes to the lower left. The lower with the right, the answer goes to the lower right. 0, 3, 2, 2. So n squared is equal to 1, 3, 0, 4. That is how we read matrices. We read matrices row by row. 1, 3, 0, 4. And what do we do with that? We will now subtract this matrix from L. When subtracting or adding matrices, we combine corresponding elements. So 3 will go with this one. So 3 minus 1 is 2. 2 minus 3 is -1. 1 minus 0 is 1, and 4 minus 4 is 0. So we have 2, -1, 1, 0. In squaring a matrix, sometimes candidate may want to square each element of the matrix, and that is incorrect. Squaring any quantity is achieved by multiplying two occurrences of that quantity together. A matrix is no exception. A singular matrix has no inverse. This is because its determinant is equal to 0. Let us find the determinant of M. So a singular matrix has no inverse, and this is because its determinant is equal to 0. So the singular matrix has determinant equal to 0, and let us show you how we work out the determinant. So there is our matrix. This is the one that we are talking about, and this is our illustrative matrix. So the determinant is given by multiply the numbers in the leading diagonal. So those two, leading diagonal, and minus the product of the elements in the subordinate diagonal. Right. Therefore, we have x multiplied by x is x squared minus 36. The determinant is equal to 0, so simplify the expression, we get x squared minus 36 is equal to 0. So here we have determinant is equal to 0, reminding us. So whatever determinant turns out to be, its value will be equated to 0, and we will solve that equation. The left-hand side of the equation is in the form of a difference of two squares that may be factorized at sight. We know how to factorize a difference of two squares already. X minus 6, x plus 6. What do we square to give x squared? X. What do we square to give 36? 6. So it is x minus 6, x plus 6. May be written x plus 6, x minus 6. Then our answer is x is equal to a positive and a negative 6. By transposing negative 36 to the right hand side, right here, so if solving this equation, we say x squared is equal to, transpose this, we get 36. So by transposing negative 36 to the right hand side, some candidates may solve the problem by taking the square root of 36. By so doing, they may neglect the fact that square roots occur in pairs. For others, it does not matter. They realize that the equation is quadratic and must therefore have two solutions. However, by keeping the difference of squares, the two values of x are more blatant and therefore less likely to be ignored. So by using the difference of two squares, it is easier for us to see the two values of x coming here. While if we did this, it is not impossible for some student to transpose this and then maintain in their mind the cognizance that the square root occurs in pairs. It is not impossible. Some students may do that still, but factorizing the difference of two squares makes it more likely. In attempting to find the values of P and Q, we may use the fact that the product of the matrix of transformation and the position vector of the point will result in the position vector of the image. Two of the elements in the matrix are equal to 0. In finding P and Q, the single point and its image will be enough. Just use one of them. So instead of writing a large equation that consists of 3 2x2 matrices, we may simplify our work because these two are equal to 0, and we will see necessarily how that will impact in the long run. So there we have our matrix equation, and we are saying that the position vector of the point, which is this one, 2, 1, is being multiplied by the matrix of transformation, and the result will be the position vector of the image. But on multiplication, what do we do? The upper with this one. So 0, 2 is 0, and P multiplied by 1 is P. Then Q times 2 is 2Q. 0 with 1 is 0. So we'll just have 2Q. We see that some of the elements that might compound the problem are eliminated by the fact that we have 0 here and 0 here. So when we multiply, we get P 2Q, and that is equal to negative 1, 2. So there's no difficulty seeing that P is equal to negative 1. Equating corresponding elements, we may be able to find the values of A and B. So P is equal to negative 1 and 2Q is equal to 2 implies that Q is equal to 1. That's not very difficult. Now we have a vector RS that translates the point 5, 3 to its image 1, 1, and we need to determine R and S. So what do we do? The position vector of the object plus the vector of translation is equal to the position vector of the image. So by transposition, we have RS is equal to 1, 1 minus 5, 3. 1, 1 minus 5, 3. So we have 1, 1 minus 5, 3. The position vector turns out to be R is equal to negative 4 and S is equal to negative 2. Before making use of the transformation represented by R followed by T, let us substitute the values found into their respective positions in the matrix and also in the vector. So remember that we have P is equal to negative 1, Q is equal to 1, and we have two positions already completed. No doubt negative 1 goes there and 1 goes there, and that's all there is to it. What about the vector? Negative 4 goes there and negative 2 goes there. There's nothing to it. So we need to use the combined transformation r followed by t in order to transform a particular point. And what is that point? That point is 8, 5. So for the combined transformation r followed by t, we may multiply by the matrix r, then add the vector t. The process may be shown in one arithmetic process, like so. So there we have 0, negative 1, 1, 0, and we are transforming the point 8, 5. So we write down the position vector of the point 8, 5. And that will be added to the vector of translation. Like regular arithmetic, multiply before we add. So we will multiply 0, 8, negative 1, 5. So 0 with the 8 is gone, negative 1 with the 5, we have negative 5. Then we have 1 with the 8 and 0 with 5. So the 0 times 5 will be gone, and we have 1 with 8. Then finally we have negative 5 plus negative 4, 8 plus negative 2. Whenever we are adding numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. Then the other one is 8 plus negative 2, or 8 minus 2, which is just 6. And that is all there is to it. Correct calculation is not enough. We need the image of the point. The answer is the position vector of the point. That is what we have right here. The position vector of the point, and not, or the position vector of the image, and not the coordinates of the point. The answer to the question will require the point in coordinate form.